In the middle of the 20th century, a mystery began to unsettle the world of medicine, a puzzle that defied every assumption doctors had held about the body. Patients arrived, unable to move at will, their limbs locked in stiffness, hands trembling uncontrollably, muscles twitching without reason. And yet, when examined, the very flesh they relied upon appeared intact. The nerves leading to the extremities were unbroken, the muscles themselves unharmed, as if the body were perfectly capable, but something invisible had severed its connection to action. It was a paradox that struck at the heart of medical understanding. How could motion, so fundamental to life, falter when the machinery itself remained untouched? The symptoms were undeniable, brutal in their consistency, yet no explanation lay in the usual places. It was not the arms, not the legs, not the spine. It was something far more elusive, something deeper, hidden in the origin of command itself. The question that haunted every neurologist, every physician who confronted these patients, was terrifying in its simplicity and revolutionary in its implication. What if the problem was not in the body at all, but in the signal coming from the brain, the very command center of thought, intention, and movement? What if the paralysis, the tremors, the rigidity were not failures of flesh, but failures of communication, a disruption in the invisible lines of instruction that should have flowed effortlessly from mind to muscle? It was a question that shattered old assumptions and demanded a radical new way of seeing the human body, not as a collection of moving parts, but as a network of messages, of pulses, of invisible orders, some of which had gone awry. And with that realization, a door opened, one that many at the time feared to even approach, because to interfere with the brain itself was to touch the sacred seat of identity, of will, and of consciousness. The very idea seemed audacious, even forbidden. Yet within that forbidden question lay the possibility of rewriting what medicine thought was possible, of restoring movement to those trapped within their own bodies, and of confronting the terrifying truth that control, even over something as simple as a hand or a step, might begin far away from the hand itself, deep inside the mind. At that time, the brain was untouchable, a sanctum of identity and consciousness, a realm no scalpel had the right to breach. To intervene within its folds was considered reckless, a gamble with the very essence of a person's self, a trespass into the most intimate domain of thought and awareness. And yet, amid the fear and reverence, a small number of neurologists began to ask a question that seemed almost heretical. What if, instead of repairing the body, instead of attempting to fix the tremor at the level of muscle or nerve, one could intervene upstream, at the origin of the command itself? It was a vision that defied convention, audacious and dangerous, one that risked not just the patient's movement, but the integrity of their mind. The idea was immediately branded as insane, ethically questionable, a venture into a territory that medicine had long sworn to leave untouched. To imagine that electricity, applied precisely to the hidden circuits of thought and motion, could correct what the brain had misfired, seemed like a fantasy bordering on hubris. Yet in that forbidden question lay a kernel of truth, the seed of an approach that would eventually reshape neurology and challenge everything we believed about the boundary between body and mind. It was a daring gamble to reach inside the brain and whisper to the signals themselves, hoping that order could be restored without destroying the soul. By the 1950s and 60s, those forbidden ideas began to move from theory to action. The first attempts were crude, almost shocking in their audacity. Surgeons would open the skull, exposing the soft, delicate folds of the living brain beneath. They would thread tiny electrodes deep into regions that no one had touched before, places that controlled movement with a precision that had seemed untouchable. Then, with a trembling hand and the weight of ethical dread pressing down, they would pass a gentle current, almost imperceptible, through the tissue. What happened next was nothing short of astonishing. Patients who had trembled uncontrollably for years, whose hands shook so violently they could not feed themselves, whose muscles stiffened against their will, suddenly became still. The tremor vanished in an instant. Limbs that had resisted command for decades moved with unexpected coordination. The room itself seemed to hold its breath as the body responded to a signal that had not come from the patient, but from an external electrical whisper. And then, just as abruptly, the effect disappeared. The current stopped, and the tremors returned. It was as if the brain had been listening, perfectly aware, obeying with meticulous precision, and then paused as if nothing had happened. The implications were staggering. The brain did not reject electricity. It did not resist. It understood it. It responded exactly as intended. Doctors were stunned. They had expected chaos, injury, confusion. Instead, they witnessed control, immediate, measurable, reversible. A living organ, long considered sacred and untouchable, had revealed a vulnerability that was also its strength. It could be guided, corrected, tuned without destruction. The tremors, rigidity, and loss of control that had seemed permanent were not inevitable. They were signals gone astray. And for the first time, someone had found a way to speak the brain's language and be heard. This revelation shattered assumptions. The body had not failed. The problem was the instruction, not the execution. And for the first time, medicine glimpsed the possibility of reshaping movement at its source, not at its endpoint. It was terrifying. It was exhilarating. It was the beginning of a revolution no one yet fully understood, and one that would eventually redefine the boundary between human biology and human agency. As the early experiments progressed, a critical truth became painfully clear. Placement was everything. The brain was not a uniform landscape, and the electrodes could not simply be inserted anywhere. The effect, miraculous as it was, depended on precise positioning within a handful of exquisitely sensitive regions. The basal ganglia, a deep cluster of neurons orchestrating the flow of movement, became the first target. Here, the brain coordinated commands that allowed the body to move fluidly, to start and stop with intention, to dance between motion and stillness. One tiny misalignment, and the harmony could collapse into paralysis. Deeper still lay the subthalamic nucleus, a small almond-shaped filter where signals were refined and errors corrected before reaching muscles. A misfired impulse here could send tremors spiraling out of control or halt movement entirely. Even a deviation of a millimeter, a fraction of the width of a hair, could turn a life-changing intervention into catastrophic failure. Above these lay the thalamus, the central relay station of commands, where signals from the cortex and deeper structures passed through like traffic on an arterial highway. Here, the brain distributed instructions to the body, ensuring that motion, timing, and balance aligned seamlessly. A misstep in this region could erase speech, collapse consciousness, or lock the body into frozen immobility. Surgeons quickly learned that success was not merely a matter of technical skill. It required an intimate understanding of an organ that resisted mistakes. Every millimeter counted. Every angle, every depth, every adjustment could mean the difference between freedom of movement and lifelong disability. The brain, once considered untouchable, had now revealed its vulnerability, but also its incredible responsiveness. It was a world where precision was not optional, it was survival. And in those narrow corridors of neurons, the boundary between miraculous recovery and irreversible harm was almost invisible. The stakes were absolute. Touch the wrong spot, and the patient could lose everything. Touch the right spot, and a tremor that had ruled a life for decades could vanish in an instant. Among all the conditions that haunted neurologists, one disease stood above the rest, reshaping the very trajectory of medicine: Parkinson's. It was not merely a disorder of the body, it was a betrayal of the most basic human command, the ability to move freely. Patients arrived with hands that quivered uncontrollably, limbs stiffened as if frozen in ice, and every motion slowed to a painstaking crawl. Simple actions like reaching for a cup or taking a step became monumental tasks, their autonomy stolen by invisible chaos. The underlying truth, once revealed, was startling. The brain itself was at war with the body. Signals meant to coordinate motion were scrambled, conflicting, drowning each other in static. Commands to move arrived too late or too weak, were in contradiction to one another. The muscles, perfectly healthy, the nerves perfectly intact, had no choice but to follow what they were given, even if what they were given was nonsense. Tremor, rigidity, slowness, these were not failures of flesh, but failures of instruction. It was here that the first experimental solution emerged, fragile and daring. Extremely thin electrodes were guided deep into the brain, threading into those critical regions where movement was orchestrated. These electrodes were not left inert. They were connected to a device implanted beneath the skin, similar in concept to a pacemaker for the heart. Once activated, the effect was immediate, almost unbelievable. Tremors that had controlled the life for decades vanished in a single astonishing moment. Limbs that had refused to obey now moved smoothly, as if awakened from a long, unyielding sleep. Doctors watched in awe as years of suffering were undone, not by drugs, not by therapy, but by a whisper of electricity, precisely placed and perfectly timed. The body, which had appeared broken and ungovernable, responded instantly to the correction of its misfiring signals. For the first time, the brain's chaos could be interrupted, its noise silenced, and human control restored, at least partially, to those who had lost it. In that moment, it became clear that Parkinson's was not a tragedy of muscles, but a tragedy of messages, and that, with careful intervention, the message could be rewritten. The technique that emerged from these early experiments eventually earned a name: Deep Brain Stimulation, or DBS. It carried a weight far beyond its letters, a promise both profound and unsettling. Yet it was not what most people imagined. This was not a technology designed to control thoughts, to rewrite personality, or to manipulate decisions. It did not program the human mind. It did not create a new person inside the skull. What it did do, and what made it extraordinary, was far subtler and far more powerful. DBS was a way to intervene in the brain's own language, to restore order to signals gone awry. It was not about replacing the brain's natural activity. It was about correcting the distortions, removing the static, and allowing the proper commands to pass through unimpeded. Every pulse, every microscopic adjustment was a careful negotiation with the organ itself, coaxing it back into its intended rhythm. The most common analogy quickly took hold among neurologists and engineers alike. It was like repairing static on a radio signal. The station, the music, the voice, the broadcast remained the same. Nothing about the content changed, but the interference that had drowned it out, that had made it impossible to understand, was removed. Suddenly, clarity returned. Harmony was restored. Movement, long disrupted, could flow again. And yet the wonder of DBS lay in its restraint. It did not force motion. It did not tell the body what to do. It did not invent coordination. It merely silenced the noise, cleared the path, and let the brain speak to the muscles as it had always intended. For decades, patients had been trapped by signals that betrayed them. With DBS, the betrayal ended, not through domination, but through precision, patience, and a quiet understanding of the brain's own rules. It was, in every sense, a conversation with the most private part of the human body, not a rewriting, not a command, but a delicate intervention, a restoration of balance. And in that restoration, lives long constrained by tremor and rigidity found movement, once more, under their own control.
Despite the dramatic transformations witnessed in patients, many misunderstood what DBS actually did. The electrodes, tiny as they were, did not act as masters of the body. They did not issue orders. They did not force muscles to obey or override the patient's own control. There was no external hand moving the limbs, no invisible conductor orchestrating motion. Instead, the truth was far more subtle, far more extraordinary. DBS functioned as a filter, a corrective lens through which the brain's own signals could pass. Trembling, rigidity, hesitation, these were not the body's fault, nor the patient's. They were errors in transmission, garbled commands that had become trapped in loops or corrupted by misfiring circuits. The electrodes intercepted these faulty signals, quieting the noise, interrupting the miscommunication, and allowing the correct instructions to flow unimpeded. Movement that had been fractured and halting became continuous, coordinated, and far more reliable. The results were immediately visible. Hands that shook uncontrollably steadied. Steps that had faltered became purposeful. Facial expressions, subtle gestures, even speech, all regained a measure of fluidity that had seemed impossible. Yet, DBS did not cure the disease. It did not rewrite Parkinson's itself, nor did it restore the brain to perfect function. What it did achieve was something almost miraculous in its simplicity. The body could listen again to the commands it had always been meant to follow. Patients experienced smoother motion, more precise control, and a tangible reduction in the symptoms that had dominated their lives. They regained the freedom to move without thinking, to act without struggle, to exist in their own bodies once more. And yet, the brain remained the brain, unchanged in its complexity, still sending billions of signals, still containing the disease that had distorted its instructions. DBS did not create perfection, it restored clarity. It created space for control to return, not as a gift from the surgeon, but as a re-establishment of the dialogue that had been lost. In this quiet correction, the brilliance of DBS revealed itself. It was not power imposed, but understanding applied. It did not dominate, it aligned. And in doing so, it allowed human motion to return to the realm of possibility, guided not by external commands, but by the patient's own neural architecture, finally able to be heard. By the time the 1990s arrived, what had once been considered fringe, experimental, and even reckless had transformed into a medical revolution. Reports of successive successes began to accumulate, each case reinforcing what the pioneers had discovered decades earlier. The brain, when approached with precision, could be coaxed back into harmony. The tremors that had defined a life, the rigidity that had imprisoned movement, the relentless slowing that had erased independence, all of it could be mitigated with a carefully placed pulse of electricity. Regulatory approvals followed, not immediately, but inevitably, as the evidence became impossible to ignore.
Hospitals that had once recoiled at the thought of opening the skull to implant electrodes now began to offer the procedure. Neurologists, surgeons, and engineers collaborated in ways that had once seemed unimaginable, guided by a shared understanding that human movement was not simply a function of muscle or bone, but of signal and timing. Parkinson's disease, essential tremor, and dystonia, conditions that had long been synonymous with limitation, found a new path forward. Patients who had surrendered to the unpredictability of their own bodies now experienced control restored in real time. With the flick of a switch, a stream of electricity delivered through minuscule electrodes allowed a hand to steady, a foot to step, a gesture to become intentional. For the first time in recorded history, a human could reclaim autonomy over their own movement through the intervention of technology delicately integrated into the deepest reaches of the brain. And it was not just recovery, it was revelation. The moment when a patient first lifted a hand that had trembled uncontrollably for years, the instant a foot obeyed a command long forgotten, represented more than medicine. It was proof that the brain, once thought immutable, could be guided with subtlety, reshaped without destroying the essence of self. The body, which had once betrayed its owner, now listened once more, not because it had been replaced, but because its signals had been restored to coherence. In those years, DBS moved from theory to practice, from experimental curiosity to life-changing intervention. Lives that had been defined by limitation were suddenly redefined by possibility. And in that restoration, the promise of a future where the boundaries of human movement could be expanded, not through drugs alone, nor through rehabilitation alone, but through an intimate dialogue with the brain itself, was finally realized.
Yet even as DBS restored control over movement, it unveiled a side of the brain that had long remained hidden, a domain far more delicate and unpredictable than tremors or rigidity. Soon after surgery, neurologists began noticing something that unsettled even the most experienced practitioners. Patients who had come seeking relief from the mechanical tyranny of Parkinson's began exhibiting changes that were neither expected nor entirely understood. Some found their moods lifted in ways they had not imagined, joy and impulsivity returning as if awakened from a long slumber. Others became more reckless, their newfound energy tinged with a sudden edge of impatience or daring. In some, depression vanished almost overnight, while in others, it emerged like a shadow that had previously gone unnoticed. The discovery sent ripples of shock through the medical community. It became painfully clear that the areas of the brain responsible for movement were not isolated from the circuits governing emotion and behavior. A pulse that eased a hand tremor could also inadvertently nudge the emotional state of the patient, shifting moods, altering motivation, even touching personality in subtle, profound ways. The control of the body was intertwined with the control of the mind. To intervene in one was inevitably to touch the other. Doctors confronted a truth that was as exhilarating as it was terrifying. Manipulating motion could no longer be seen as purely mechanical. It carried the weight of ethical uncertainty. A hand restored could come with an unanticipated change in temperament. A step regained could be accompanied by a shift in desire or impulse. The very techniques designed to liberate the body revealed how finely balanced the human brain truly is, and how thin the line separating movement from mind, command from consciousness, truly remained. In this realization, the field of neurology faced an unprecedented frontier. The brain was not merely a machine to be corrected. It was a living system in which body and psyche were inseparable, where every intervention resonated far beyond the immediate symptom, whispering into the uncharted territories of identity itself. Control over the body, it seemed, came with a shadow.
the invisible hand of influence that could not help but touch the deepest corners of the human self. It is a question that haunted everyone who witnessed DBS in action. Was this mind control? The answer, as reassuring as it may seem, was more complicated than a simple yes or no. Deep brain stimulation did not implant ideas. It did not dictate choices, nor did it erase free will. Patients remained themselves, fully aware, fully conscious, fully human. No thoughts were forced, no memories rewritten, no personality overwritten by electricity. And yet, the influence of DBS was undeniable. Movement, once trapped in a loop of tremor and rigidity, could flow freely again. Muscles obeyed commands that had long been ignored. But alongside these physical transformations came subtler shifts, changes in mood, in motivation, in the very force that drove action. Some patients found a spark of energy where there had been inertia. Others discovered calm where once there had been restlessness. Occasionally, behavior itself would shift, not as a direct command, but as a ripple through the interconnected web of neural circuits. It became painfully clear that the line between body and mind, between motion and emotion, between control and influence, was impossibly thin. To restore the hand's function was also to touch the mind's resonance. To adjust the signal that allowed a foot to step was also to nudge the currents that carried desire and impulse. The brain did not segregate experience neatly into compartments, and neither could technology. Every intervention carried a consequence, sometimes subtle, sometimes profound, but always present. And in that delicate intersection lay the ethical tension, the quiet disquiet that accompanied every success. DBS was a miracle of precision, restoring autonomy and motion where none had existed. But it reminded the world that even the most targeted technology could never be divorced from the human being it sought to heal. The boundary between physical liberation and psychological impact was razor thin, and walking that edge required both humility and vigilance, for every pulse that freed the body also whispered to the mind. The moment DBS crossed from experimental procedure to clinical reality, it ignited a storm of ethical questions that has never fully subsided. If a pulse of electricity could restore movement, could it also reshape the self? When the tremor stops, when rigidity eases, is the patient who they were before, or someone subtly altered by the intervention? Each success carried with it a shadow of doubt. To what extent does technology change the person it heals, and where does the responsibility lie for those changes? Every adjustment of the device, every calibration carried weight beyond the purely medical. Missteps could have consequences not just for movement, but for behavior, for personality, for the intangible essence of identity. Could a poorly placed or mismanaged electrode turn treatment into manipulation? Could the same technology that frees also be used to coerce, to control, to override choice? These were not hypothetical musings. They were real questions faced in operating rooms and ethics boards, in research papers and patient consultations. The debate reached far beyond the hospital walls. Philosophers, neurologists, ethicists, and engineers all weighed in, grappling with ideas that had no precedent in human history. DBS did not merely heal, it intruded into the intimate intersection of body, mind, and self. The very notion of autonomy became slippery, reframed by the realization that a device, imperceptibly small, could influence the motions and impulses that define a life. And yet, despite decades of research, trials, and discussion, there is still no definitive answer. The questions linger, unresolved, hovering over every operating table, every consultation, every patient whose life has been touched by this extraordinary technology. DBS is not just a tool of medicine, it is a mirror reflecting the fragile boundary between healing and intervention, between the restoration of function and the essence of who we are. The debate remains open, complex, and inescapably human, a reminder that the deeper we reach into the brain, the more profoundly we confront the mysteries of identity itself. As the calendar turned into the 21st century, deep brain stimulation evolved from a delicate experiment into a field defined by precision, adaptability, and intelligence. The rudimentary electrodes of the past, which had delivered uniform pulses to broad areas of the brain, gave way to instruments of astonishing accuracy, capable of targeting regions smaller than a grain of rice with a specificity that once seemed impossible. The stimulation became not just a matter of electricity, but a conversation, one that required careful timing, sensitivity, and understanding of the brain's own rhythms. This era introduced guided stimulation, a method that could focus pulses only where they were needed, sparing neighboring circuits and minimizing unintended effects. Surgeons and engineers collaborated as never before, refining placement with imaging technology that mapped the brain's deepest structures in 3 dimensions. And then came the integration of artificial intelligence, a silent observer within the system, analyzing the flurries of neural activity in real time. These intelligent systems no longer operated on a fixed schedule. They responded to the brain's own signals, detecting disruptions, misfires, or tremors as they emerged, and delivering corrections only when necessary. Closed-loop systems, as they are called, represent a profound shift in how humans interact with the brain. The device no longer commands indiscriminately. It listens, interprets, and intervenes with precision. It waits, unobtrusive, for a signal of dysfunction, and then acts in a fraction of a second to restore balance. The brain itself dictates the timing, the severity, the very presence of stimulation, creating a partnership between human tissue and technology that blurs the line between control and cooperation. In this new paradigm, DBS has become more than a treatment. It is a dialogue. The brain's own errors are acknowledged and corrected without overriding its intelligence. The system acts as a guardian, a mediator, a subtle guide that respects the autonomy of the neural circuits even as it restores function. The technology has grown beyond brute force intervention into an art of harmonizing with the brain's intricate symphony, maintaining movement, alleviating symptoms, and preserving as much of the patient's identity as science can allow. But the story of deep brain stimulation does not end with movement alone. In the decades since its inception, the technology has crossed a threshold, venturing into realms of the mind that were once thought untouchable, territories where medicine had little influence. Epileptic seizures, sudden and violent, can now be tamed, their chaotic electrical storms moderated by pulses delivered deep within the brain. Obsessive-compulsive behaviors, once rigid chains that bound thought and action, can be loosened, granting patients a freedom of mind they had long been denied. Depression, resistant to every pill and therapy, finds a new doorway to relief as carefully targeted stimulation quiets circuits gone awry. Even chronic pain, relentless and invisible, can be eased as DBS subtly recalibrates the brain's perception of suffering. With each new application, the boundary between body and psyche dissolves further. Deep brain stimulation has moved beyond the mechanical, beyond the restoration of simple motor function. It now touches the very essence of experience, altering patterns of thought, mood, and perception. The technology that once tamed the tremor of a hand now interacts with circuits that define desire, fear, and hope. In a sense, it has exited the domain of flesh and entered the domain of the mind itself, operating not just on what the body does, but on how the person feels, how they react, how they exist within themselves. It is a shift as profound as it is unsettling. DBS is no longer simply a medical intervention. It is a bridge between anatomy and consciousness, a tool that navigates the fine, tangled web where neurons shape identity. It has ventured into the invisible landscape of emotion and cognition, demonstrating that to heal the brain is to touch the soul, and that to restore control over the body is to inevitably influence the mind. The device hums quietly beneath the skin, a hidden conductor orchestrating signals that shape both motion and meaning, reminding us that in the 21st century, the frontier of medicine is no longer only external. It is internal, intimate, and deeply personal.
And now, as the 21st century unfolds, the story moves beyond stimulation and therapy, reaching toward a horizon once reserved for imagination and science fiction, the direct interface between brain and machine. Brain-computer interfaces, the next evolution of neural technology, promise to translate thought into action without the need for muscles, tendons, or even speech. Paralysis, once an unyielding barrier, can be bypassed. Fingers may move, cursors may glide, prosthetic limbs may respond, all at the speed of thought. The mind, untethered from the limitations of the body, becomes the command center, sending instructions that machines faithfully execute, restoring a degree of autonomy that was previously unimaginable. The implications are staggering. For those who have spent years trapped within their own bodies, confined by the cruelty of disease or injury, these interfaces offer a new lease on life. A person can write, paint, or play, can grasp, manipulate, and explore, all through the invisible threads of thought connected to technology. Yet with this potential comes an unspoken tension, a reminder that as we merge with machines, the line between human intention and technological mediation blurs. What was once purely biological becomes intertwined with code, sensors, and algorithms, creating a partnership that is both miraculous and profoundly delicate. The first steps are no longer theoretical, they have already been achieved. Patients have moved cursors, commanded robotic limbs, and regained fragments of independence through the bridge between brain and machine. These early successes are a glimpse into a future where physical limitations no longer define the boundaries of human capability. But the journey is only beginning. Each breakthrough raises new questions about identity, control, and responsibility, echoing the ethical complexities that accompanied the first pulses of electricity in the brain decades ago. The path forward is both thrilling and uncertain. We are learning not just to heal, but to communicate directly with the organ that defines our existence, translating thought into action with a clarity that was once impossible. And in this quiet revolution, the promise is profound. The mind may finally reclaim power over the body in ways that were unimaginable, and humanity may step into a new era where the barriers of flesh are no longer absolute, where hope, movement, and choice can emerge from circuits and neurons working together in harmony to restore what was once lost. The frontier is no longer outside. It lies within, waiting for those willing to explore the vast, untapped universe of the human brain.